The most powerful artificial intelligence model in the world may not become the most important one. That sounds wrong. Technology markets are usually described as races: the fastest chip, the largest network, the smartest model, the highest benchmark score, the most impressive demonstration. Investors watch capability charts. Developers compare reasoning tests. Companies announce that a new system is better at coding, mathematics, science, law, medicine, and long horizon tasks. The frontier receives the attention. The cheapest useful model may receive the work. That is the difference between winning the demonstration and winning the economy. A company can admire the strongest model and deploy a cheaper one. A developer can test the frontier and route 90% of production traffic somewhere else. A consumer can prefer the most intelligent assistant and still use the free assistant already built into a phone. An enterprise can pay a premium for difficult decisions and use a small model for everything routine. The AI market is beginning to discover an old business: the best product does not always win. The product with the best economics often does. This does not mean intelligence stops mattering. It means intelligence must be priced. The relevant question is not which model is smartest. It is, how much useful work does the model produce for every dollar? Second, what and unit of human attention? That is a different competition. A frontier model may solve 95 tasks out of 100. A cheaper model may solve 92. If the frontier model costs 10 times more, the cheaper model can be the better business decision. The missing 3 tasks can be sent upward. This is the foundation of model routing. Use inexpensive intelligence for common work. Escalate difficult work to premium intelligence. The result can be nearly the same quality at a fraction of the cost. The strongest model becomes the specialist. The cheaper model becomes the work. Specialists receive prestige. Workforces receive volume. Volume can decide the winner. The first era of generative AI was dominated by capability. Companies wanted to prove that the technology worked. A model that could write, reason, code, and answer questions felt extraordinary. Customers tolerated high costs because the alternative did not exist. The second era is dominated by deployment. The question changes from, can AI do this? To, can AI do this 10 million times without destroying the budget? A prototype sends 1,000 requests. A production system sends 1 billion. At 1,000 requests, price differences look small. At 1 billion, price becomes strategy. This is why the cheapest model may win. Not because companies stop caring about quality. Because scale turns small costs into large numbers. Imagine a customer service assistant. It receives one question, reads the customer's history, checks a policy, drafts an answer. A human reviews it. The model cost appears tiny. Now multiply the process by every customer, every day, across several countries. Add repeated prompts, tool calls, long context, reasoning tokens, retries, safety checks, translation, monitoring. The tiny cost becomes a budget line. Then the company adds an agent. The agent does not call the model one. It plans, searches, reads, writes, checks, corrects, asks another model, runs a tool, receives an error, tries again. One user request can create dozens or hundreds of model calls. The price of intelligence compounds inside the workflow. A 10-cent interaction can become a $10 task. A $10 task can become an economic product. The user sees one answer. The company sees an inference tree. Every branch costs money. This is the hidden economics of AI agents. The model that looks affordable in a chatbot can become expensive inside autonomy. Agents turn token prices into labor costs. The more independent the agent becomes, the more important efficiency becomes. This is why model providers offer families: large models, medium models, mini models, nano models, fast models, flash models, reasoning models, premium models. The names differ. The strategy is the same. Different intelligence for different prices. A market is learning that one model should not do everything. A company does not use a chief executive to answer every support ticket. It does not hire a lawyer to schedule every meeting. It does not use a supercomputer to run a calculator. AI systems will organize labor the same way. The expensive model handles ambiguity, risk planning, and difficult reasoning. The cheaper model handles classification, extraction, summarization, formatting, routing, and routine conversation. The smallest model may operate on the device. The medium model may run continuously. The frontier model may enter only when confidence falls. This creates a hierarchy of machine labor. The cheapest model can sit at the bottom of every work. The bottom receives the most volume. That position can be more valuable than the top. Cloud computing followed a similar pattern. The most powerful machine was not used for every workload. Companies chose different instances. Small servers for small jobs, large servers for large jobs, storage classes for different access patterns, cheap capacity for flexible work, premium capacity for urgent work. The cloud became efficient through allocation. The AI is moving toward intelligence allocation. The customer will not ask for a model by name every time. A control layer will choose. The request enters. The router estimates difficulty. A cheap model tries first. An evaluation system checks confidence. A stronger model receives the difficult cases. A specialist model handles code. Another handles images. A local model handles private data. The user receives one experience. Behind it is support. In this world, the cheapest model can win without becoming the brand. It becomes the invisible default. The premium model receives the difficult 10%. The cheap model receives the profitable 90%. The economics resemble payment. Consumers know the store. They may not know the infrastructure processing the transaction. The provider underneath can become enormous. I may develop the same hidden winners. A low-cost model powers support tools, internal agents, search systems, devices, games, robots, and applications. Users rarely see its name. Developers see the bill. The bill drives adoption. Price competition is already visible in official API menus. Providers list prices for input tokens, cached input, output tokens, batch processing, priority service, and long contexts. The table itself tells the story. Intelligence is being unbundled into measurable units. One price for reading, another for speaking, a discount for repeated context, a discount for waiting, a premium for speed, a premium for deeper reasoning, a premium for data residency. The model is not sold as one thing. It is sold like infrastructure. This changes how companies optimize. A team once asked, "Which model should we use?" It now asks, "Which model, service tier, cache policy, batch window, context length, output limit, and routing rule should we use for each step?" The answer determines gross margin. An AI application can grow revenue and lose money at the same time. Users love it. Usage rises. Every interaction triggers expensive inference. Subscription revenue remains fixed. Cost rises with engagement. The most active customers become the least profitable. This is the opposite of traditional software. A normal size product can serve another user at low marginal cost. AI software often pays whenever the user asks for work. The business looks like software on the outside and the utility on the inside. The application owner must control consumption. Cheaper models can turn a bad business into a good one. Suppose a company charges $20 per month. A light user costs $1 in inference. A heavy user costs $30. The average can destroy the product. The company adds limits. Customers complain. It raises prices. Competitors undercut it. Then a cheaper model arrives. The same tasks cost $5 for the heavy user. The subscription becomes profitable. The cheaper model has not only won the workload, it has made the product possible. This is why low-cost intelligence can expand the market. A price cut does more than move customers between providers. It creates new use cases. Tasks that were too expensive become ordinary. The company can analyze every support call instead of sampling a few, review every contract instead of only large ones, translate every message, generate personalized education for every student, monitor every machine, add intelligence to every device, run agents continuously rather than occasionally, lower cost increases frequency. This is Jevons paradox applied to intelligence. When a resource becomes more efficient, total consumption can rise. Cheap models may reduce cost per task and increase total spending on AI. The provider charges less for each unit. It sells far more units. This is how commodities create empires. Electricity became cheap enough to enter every room. Computing became cheap enough to enter every pocket. Storage became cheap enough to preserve everything. Bandwidth became cheap enough to stream video. Intelligence may follow. The winning model may not be the one reserved for important moments. It may be the one used without thinking. A feature becomes universal when the price disappears from the user's mind. People do not calculate the cost of each web search. They do not think about the processor cycle behind every tap. AI must reach the same level. The cheapest model has a path toward ubiquity. Ubiquity creates data, ecosystem, integration, and habit. These advantages can improve the model's position beyond price. Developers build around it. Software vendors support it. Tools optimize for it. Hardware runs it efficiently. Training materials appear. Employees learn its behavior. The cheap model becomes the standard. Standards are difficult to displace. The premium model can be better and remain a premium option. The standard receives the ecosystem. This happened with technology repeatedly. The technically superior format did not always win. The best product did not always become the platform. Distribution, compatibility, and price mattered. AI will not escape these forces. The phrase cheapest model can be misleading. Sticker price is only one number. The cheapest model per token may be expensive per successful task. A weak model can generate an incorrect answer. The system retrieves. The user corrects it. A human reviews the result. The agent enters a loop. The company loses a customer. The apparent saving disappears. The true metric is cost per successful outcome. This is the number every serious AI buyer will eventually calculate. Total model cost, plus tool cost, plus latency, plus errors, plus human review, plus security, plus monitoring, plus integration, plus failure. A premium model can be cheaper if it completes the task once. A discount model can be expensive if it fails repeatedly. The cheapest AI model may win only when cheapest means economically cheapest, not merely lowest advertised price. This distinction is critical. Benchmarks measure capability. Invoices measure tokens. Businesses measure outcomes. The winning provider must connect all three. Consider code generation. A cheap model writes a patch quickly. The patch contains a subtle bug. A developer spends 2 hours reviewing and correcting it. The API cost was almost nothing. The labor cost was high. A stronger model produces a correct patch. The API cost is higher. The developer approves it in 10 minutes. The stronger model was cheaper. Now consider classification. A company routes emails into 10 categories. The task is simple. A small model is nearly as accurate as a frontier model. The stronger model adds no meaningful value. The premium price is waste. The smaller model is cheaper and better for the business. There is no universal cheapest model. There is a cheapest model for each task. This creates an enormous opportunity for routing companies, evaluation platforms, and AI-controlled playing. They do not need to build the strongest model. They need to select the right one. The router can become more valuable as model competition increases. One provider lowers prices. Another improves coding. Another offers better privacy. Another runs locally. The router measures performance and sends work accordingly. The application avoids dependence. The model providers become interchangeable suppliers. This is good for customers. It is dangerous for model company margins. Every provider wants to avoid commoditization. A model company does not want to compete only on cost. It wants a brand, developer ecosystem, unique capabilities, enterprise contracts, proprietary tools, memory, agents, applications, cloud integration. The model becomes one layer inside a larger platform. This is why frontier laboratories are moving upward and downward at the same time. Downward into infrastructure and chips, upward into products and workflows. If the model itself becomes cheap, value moves elsewhere. The company tries to own the assistant, coding environment, business process, or agent platform. The cheap model war pressures every provider to bundle. A model that is only an API can be replaced. A model inside the customer's daily workflow is harder to remove. The price war therefore changes strategy. Providers cut token prices while expanding platform control. The customer pays less for raw intelligence and more for everything around it. This is familiar from cloud computing. Compute prices fell. Cloud bills grew. The services multiplied. Databases, security, networking, analytics, managed platforms. AI can follow the same path. Token prices fall. AI spending rises through agents, tools, data, memory, evaluation, governance, and enterprise integration. The cheapest model may win the token market. Another company may capture the profit above it. This is the first major paradox. Winning usage does not guarantee winning profit. A provider can offer extremely low prices and attract massive traffic. If infrastructure cost remains high, the business loses money. A rival can sell a more expensive model with strong enterprise margin. Which one has won? It depends on the goal. Market share, revenue, profit, ecosystem, strategic influence. A cheap model can be a weapon rather than a standalone business. A cloud provider can subsidize a model to sell computing. A hardware company can release models to increase chip demand. A social media company can offer open weights to prevent competitors from owning the intelligence layer. A large platform can bundle AI at low cost to defend its ecosystem. A government can support cheap models for national capability. The price does not always reflect, it can reflect strategy. This makes the AI price war difficult to read. A startup sees an inexpensive API and assumes the price is sustainable. The provider may be buying market share. A company builds a product on it. Later, the price changes. The service limits access. The model is retired. The developer discovers that cheap intelligence created expensive dependence. Total cost includes switching risk. An enterprise, therefore, cares about more than the current rate. Capacity, reliability, rate limits, data policy, support, mal stability, regional availability, contract terms. The cheapest provider can lose if procurement sees too much risk. This is why established cloud channels matter. A slightly more expensive model available through an approved platform can be easier to buy. The invoice joins an existing contract. Security is reviewed. Data stays in a known region. Support exists. The procurement cost falls. The model price is only one part of the purchase. Enterprise buyers calculate organizational friction. A cheap model requiring months of legal and security review can be costly. A premium model already approved can launch tomorrow. Time has value. This creates room for several winners. The lowest cost provider wins price-sensitive workload. The trusted provider wins regulated work. The frontier provider wins difficult tasks. The local model wins privacy. The integrated provider wins convenience. The open model wins control. The market does not choose one model. It chooses an architecture. The title still matters because one layer can dominate that architecture. The most common default can become the center of gravity. If a cheap model handles most requests, every developer optimizes around it. The expensive models become exceptions. The default can shape the market even without taking all revenue. It becomes the base layer of machine intelligence. Base layers create power. The operating system was not always the most visible application. The database was not always the most visible software. The network protocol was not the most exciting product. They controlled the environment. A cheap model can become the default reasoning substrate. Every application assumes it is available. Every device includes it. Every workflow calls it. The provider gains distribution and influence. The difficult question is whether the base layer remains differentiated. As several models become equally cheap and capable, the layer becomes a commodity. Customers switch. Margins fall. Open source models accelerate this possibility. When weights are available, companies can run models on their own hardware or through competing hosts. The price approaches infrastructure cost plus support. One host undercuts another. The model creator may earn little from inference. Value moves to hardware, cloud data integration, and application. Open models create a ceiling on proprietary pricing. A closed provider can charge a premium only when capability, reliability, or convenience justifies it. This is good for users. It makes the model business harder. DeepSeek became a symbol of the cost challenge because it showed how quickly high capability and low API pricing could coexist. Its pricing tables were not only marketing. They were a threat to assumptions about how much intelligence should cost. Other providers responded with smaller models cashing discounts, batch tiers, faster architectures, and price cuts. The market learned that tier capability can move downward faster than expected. Yesterday's premium intelligence becomes tomorrow's cheap model. This compression is relentless. A frontier laboratory spends billions to create a lead. Competitors learn from the architecture. Open research spreads techniques. Hardware improves. Distillation transfers behavior. Quantization reduces precision. Software kernels become faster. Serving systems become more efficient. The lead narrows. The price falls. The frontier moves again. The model company lives on a treadmill. It must keep spending to preserve differentiation. The cheaper models follow behind and capture the mature workload. This resembles pharmaceuticals. A company develops a new drug. The protected product turns premium margins. Later, generic versions reduce price. AI moves much faster. The generic period can begin within months. The frontier model earns a temporary premium. The efficient follower can receive the volume. The business question becomes, how long can the capability premium last? If the answer is short, the cheapest model may win the lifetime economics. The frontier creates the category. The low-cost model industrializes it. Innovation history contains this pattern. The first computers were rare and expensive. The largest market came from cheaper machines. The first mobile phones were luxury devices. The global market came from affordable handsets. The first cloud deployments were specialized. Commodity infrastructure expanded adoption. The first AI models showed possibility. The cheap models can make intelligence ordinary. Ordinary technology changes the world more than impressive technology. A model used by a few experts creates demonstration. A model used in every process changes productivity. Price is the bridge between them. The cheapest model is not created by one breakthrough. It is created by hundreds of small efficiencies stacked together. Architecture, data, hardware, serving, caching, scheduling, compression, software, product design. Every layer can remove cost. Mixture of experts' architectures are one example. A model can contain a large number of parameters without activating all of them for every token. Only part of the network handles each request. The model keeps broad capacity while reducing computation. The basic idea is similar to a company with many specialists. Every employee does not attend every meeting. The system routes work to the relevant experts. This can improve efficiency. It also creates engineering complexity. Routing must be balanced. Hardware must stay utilized. Communication between devices could become expensive. The architecture only wins when the whole system is optimized. DeepSeek's earlier models helped popularize the commercial importance of this approach. The headline number described a very large model. The active computation was much smaller. The lesson spread beyond one company. Model size and serving cost are not the same thing. A large model can be sparse. A smaller model can be inefficient. The customer sees tokens. The provider sees activated parameters, memory movement, communication, and utilization. The cheapest provider wins invisible engineering battles. Distillation is another force. A powerful teacher model produces examples, reasoning patterns, or preference data. A smaller student learns from them. The student does not become identical. They can capture enough behavior to handle a targeted task at lower cost. This creates a cascade. The frontier model discovers capability. The smaller model inherits part of it. The premium becomes standard. A company may use the frontier system to generate training data for its own specialized model. The expensive model helps create a cheap competitor. This is one reason model companies place limits around distillation and output use. The economic incentive is strong. A business does not need a general genius if it can train a focused worker. A bank may need a model that understands its documents and workflow. A retailer may need product classification and customer support. A factory may need maintenance analysis. A specialized model cannot perform a larger general system on the narrow task while costing less. Specialization attacks the frontier premium. The general model remains valuable for unknown questions. The specialist wins repeated work. Most enterprise processes are repeated work. This is why vertical models can survive even when frontier systems improve. They combine lower cost with domain fit. Fine-tuning creates another path. The company starts with a base model. It trains the system on examples of the desired output. The model becomes more consistent. Prompts can become shorter. Records can fall. A smaller fine-tuned model can replace a larger prompted model. The price improvement appears in several places. Lower token rate, less context, shorter instructions, fewer errors, reduced human review. The visible model is smaller. The larger saving comes from workflow efficiency. Quantization reduces the precision used to represent model weights. The model can consume less memory, run on cheaper hardware, fit on one device instead of several, produce tokens faster. Some quality can be lost. The engineering goal is to remove precision the task does not need. Human language tolerates approximation. A model does not always require the same numerical detail across every calculation. Quantization turns that tolerance into economics. It also expands local deployment. A model that once required a data center can run on a workstation, phone vehicle, or industrial computer. The marginal cost changes. The company buys hardware once. It does not pay an external API for every request. This does not make local AI free. The hardware is cost. Electricity, maintenance, engineering, updates. The economics can become attractive at high volume or when privacy matters. The local model creates strategic independence. No network delay, no external rate limit, no third-party data transfer, no provider changing the price overnight. This is why device companies care deeply about small models. A phone maker can include intelligence as a feature. The user does not see a token bill. The model helps sell hardware. The cheapest model may win because someone else pays for it. The device margin subsidizes AI. The operating system uses the model to keep users inside the ecosystem. The model provider does not need direct API revenue. This is another reason price is strategic rather than simple. An open model running locally can be economically free to the user and strategically valuable to a platform. Prompt caching is one of the clearest examples of cost optimization. Many AI applications repeat large blocks of context, system instructions, tool definitions, company policies, long documents, conversation history. The first request requires computation. Later requests can reuse part of the work. Providers offer large discounts for cached input. OpenAI says prompt caching can reduce input costs dramatically and lower latency when repeated prefixes match. Anthropic prices cache hits far below normal input for supported models. Google offers syntax caching across its Gemini API. DeepSeek lists separate traits for cache hits and misses. The details vary. The message is universal. Repeated knowledge should not be paid for as if it were new. This changes application design. Place stable instructions first. Reuse common context. Separate static documents from changing user data. Group requests around shared prefixes. Monitor cache hit rates. The prompt becomes an economic object. A badly structured prompt can waste money. A well-structured one can improve margin without changing the model. This creates a new engineering discipline, AI cost optimization. The company does not only write prompts for quality. It writes prompts for cacheability. Batch processing creates another discount. Not every task needs an immediate answer. A company can classify yesterday's support tickets overnight. Generate summaries before the morning. Evaluate models in the background. Process document archive. Create embeddings. Providers can schedule this work when capacity is available. The customer receives lower pricing. The provider improves hardware utilization. OpenAI's Batch API, for example, offers a significant discount for work that can complete within a longer window. Other providers use similar ideas. Flex tiers, off-peak pricing, reserves throughput, asynchronous processing. The economic principle is familiar from airlines and electricity. Urgency costs money. Flexibility creates discounts. A company treating every AI request as real-time overpays. The cheapest model strategy includes deciding when the answer is needed. Latency is a product feature and a cost driver. A customer-facing voice assistant needs speed. A monthly compliance report does not. The same company can pay premium rates for one and batch discounts for the other. The winning AI architecture understands time. Output length matters even more than many buyers realize. Model providers often charge more for output than input. Generating each token requires sequential work. A model cannot produce the final word before producing the earlier ones. Long answers consume time and capacity. A verbose model can be expensive even with a low input rate. Product design can reduce cost by asking for concise outputs, structured fields, short classifications, tool calls instead of explanations. The user may prefer brevity. The business saves money. This creates an unusual incentive. A chatbot may sound impressive because it writes a long answer. A production agent should often say less. The cheapest useful model may be the one that knows when to stop. Reasoning models complicate this. They can spend hidden or visible tokens thinking before answering. The deeper reasoning improves difficult tasks. It also increases cost and latency. The user sees one paragraph. The provider may have generated a large internal computation. The application designer must decide which tasks deserve thought. A simple extraction should not trigger an expensive reasoning process. A complex legal analysis may justify it. The cheap model can act as a triage system. Is this easy? Handle it. Is this uncertain? Escalate. The triage decision becomes financially important. If the router sends too much work upward, costs rise. If it keeps difficult tasks below, quality falls. Routing itself needs evaluation. This creates another market around model selection. Platforms test requests against model performance. They learn patterns. Code task, multilingual task, long document, sensitive data, fast response, low budget. The system chooses the provider and service tier. A mature application may change models without the user noticing. This weakens model brand. The customer buys an outcome. The router shops for intelligence. Providers become bidders. The cheapest qualifying model wins each request. This can create an automated spot market. The analogy is not perfect. Models have different behavior. Switching can alter tone, safety, and output. Evaluation systems can manage the difference. The more standardized APIs and structured outputs become, the easier substitution gets. OpenAI-compatible interfaces accelerate switching. DeepSeek and other providers support familiar API formats. Cloud platforms offer several model families behind one environment. Frameworks abstract provider details. The cost of moving falls. Price competition intensifies. Model companies respond with proprietary features. Unique tools. Large context windows. Fine-tuning. Guaranteed capacity. Agent platforms. They try to make comparison harder. Commodities are easy to price. Platforms are harder to replace. The customer tries to standardize. The vendor tries to differentiate. This struggle will shape margin. Hardware is the deepest layer. Inference cost depends on how efficiently chips move data and perform calculation. A model can be mathematically elegant and expensive on available hardware. Another can map cleanly to accelerators. Memory bandwidth, interconnect, batch size, precision, power consumption, cooling, server utilization. These details determine price. The provider with the best model is not automatically the provider with the lowest serving cost. A cloud company can optimize chips and software together. Google designs TPS and Gemini systems. Amazon designs Tray, NIU, and Inferent IA. Microsoft develops custom accelerators while buying large amounts of external hardware. NVIDIA builds GPS, libraries, and inference software. Chinese companies pursue domestic accelerators under supply constraints. The model price war is also a hardware war. A provider with cheaper compute can undercut competitors or preserve higher margin. This is why model companies sign enormous infrastructure agreements. The front-end product may look like a chat window. The cost structure looks industrial. Data centers, power plants, chip supply, construction, long-term capital. The cheapest model may win because it runs on the most available hardware. A model requiring rare premium chips can face capacity limits. A model optimized for several hardware types can scale more easily. Portability creates bargaining power. If the provider can move workloads between NV, IDI DPS, Google TPS, Amazon chips, and other system suppliers compete. If the model depends on one stack, the hardware company captures margin. Open source software can improve portability. Compilers, kernels, runtimes, and inference engines translate models across devices. These tools rarely receive public attention. They can reduce serving cost more than a benchmark improvement. An optimized kernel makes the same model cheaper. A better scheduler increases utilization. Continuous batching combines requests. Speculative decoding uses a small model to predict tokens that a larger model verifies. The fast model runs ahead. The expensive model checks. If predictions are correct, generation accelerates. This is a literal example of a cheap model helping a premium model become cheaper. The industry will use more hybrid systems like this. Small models draft. Large models verify. Specialists use tools. Routers assign work. The idea of one model producing one answer becomes outdated. The final output can be assembled by an economy of models. The cheapest participant can receive an enormous volume even when it does not control the final response. Speculative decoding reveals a larger truth. Cheap intelligence can complement expensive intelligence rather than replace it. A small model can summarize documents before a large model reads them. Filter irrelevant data. Generate candidate answers. Check formatting. Classify risk. Monitor output. The frontier model becomes a scarce executive. The smaller models become staff. The total system outperforms a frontier-only architecture economically. The premium provider may encourage this because lower system cost increases usage of the premium model. The cheap model wins a role. The expensive model keeps high-value tasks. Competition and complementation coexist. Data quality is another cost lever. A well-trained smaller model can beat a larger, poorly trained model. The quantity of parameters receives attention. The selection and quality of data can matter more. Clean examples. Balanced languages. High-quality code. Domain-specific documents. Synthetic data. Preference data. The model learns useful patterns with less waste. Training efficiency lowers the capital required to create the model. This matters for competition. Only a few companies can spend unlimited amounts. Efficient laboratories can challenge them through better data and architecture. DeepSeek's rise changed perception partly because it suggested that a company could produce strong capability with a different cost structure. The exact accounting of model training is often disputed. The strategic effect was clear. Investors and developers stopped assuming that the most expensive training run automatically created the most competitive product. Efficiency became a source of prestige. The frontier race once displayed scale as proof of strength. The price war displays frugality as strength. This can reshape national competition. The United States leads in many frontier models, cloud platforms, and advanced chips. China has strong incentives to optimize around hardware constraints and serve enormous domestic demand. European companies emphasize efficiency, multilingual capability, openness, and sovereignty. Countries without giant compute budgets can build smaller local models. The cheapest capable model can spread across markets that cannot afford premium APIs. Language coverage matters. A global provider can charge an alt price and reach billions of users. Local competitors can specialize. AI adoption does not occur only in wealthy technology companies. It enters call centers, schools, small retailers, government offices, farms, clinics, and factories. These buyers care about cost. A model priced for Silicon Valley can fail globally. A model that runs on ordinary hardware can win emerging markets. This is another path to volume. Cheap models can become geopolitical infrastructure. A country can translate public services, support local languages, run systems without dependence on foreign cloud, deploy models across government devices. The value is not only saving tokens, it is sovereignty. Open weights and local hosting can make the model strategically cheaper even when technical operations cost. The country avoids sanctions risk, service withdrawal, and foreign data exposure. Total cost includes political dependence. This is why governments may support domestic models that are not the best globally. The model is good enough. It is controllable. That can be the winning combination. The consumer market has its own version. Most users do not need frontier reasoning for every interaction. They ask for rewriting. Summaries, simple advice, recipes, planning, questions. A fast, cheap model can feel better because it responds immediately. Latency is part of intelligence as experienced by the user. A slow genius can lose to a fast assistant. People value flow. A voice conversation requires low delay. A game character must respond in real time. A smart device should work offline. A child using an educational tutor cannot wait 30 seconds after every sentence. The cheapest model can also be the fastest. Speed creates engagement. Engagement creates habit. Habit creates distribution. Premium intelligence can remain available behind an escalation button. Most users may rarely need it. This resembles cameras. Professional cameras are better. Phone cameras receive most photographs. The phone camera wins through availability, convenience, and good enough quality. A small model inside every device can become the phone camera of intelligence. Always present. Private, instant. Integrated, not the absolute best. Used constantly. The device manufacturer gains leverage over cloud model providers. It can handle common asks locally and send only difficult work to the cloud. Cloud usage falls. Privacy improves. The company can negotiate better rates. The hybrid architecture becomes standard. This is why local AI changes the pricing power of frontier laboratory. The cloud provider can no longer assume every interaction requires its API. It must offer enough quality or unique capability to justify escalation. The local model sets a free baseline. The frontier price is measured against it. Open source models set another baseline. A developer can download a model and estimate self-hosting cost. The hosted provider must beat that cost after accounting for convenience, reliability, and engineering. This discipline pushes prices down. Self-hosting is not always cheaper. At low volume, an API is easier. At high, steady volume, owned or reserved infrastructure can win. Workload shape matters. Spiky demand benefits from cloud elasticity. Predictable demand benefits from capacity planning. Sensitive data benefits from local control. The cheapest choice changes over time. This creates a consulting and FinOps market. Companies need to model total AI cost, token volume, cache rate, peak load, hardware utilization, staff, energy, provider discounts, failure rates. The finance department once tracked cloud bills. It will track intelligence bills. Every agent, model, and workflow receives a cost center. Budgets enforce routing. The cheap model becomes part of corporate policy. Use the approved small model by default. Premium reasoning requires justification. Human organizations already manage travel this way. Economy class for routine trips. Business class for exceptional cases. AI procurement will create similar rules. The strongest model becomes business class. Desired, useful, not used for everything. The cheapest qualified model becomes economy class. That is where most passengers sit. This comparison reveals why branding alone will not protect premium pricing. Enterprise buyers can measure. They run evaluations, compare output, calculate error rates, negotiate volume discounts. A consumer may pay for emotional preference. A procurement department creates a spreadsheet. The provider must prove return. As models converge, price receives more weight. Capability differences matter less when all providers pass the market moves from innovation to competition. This is the moment when cheap products often win. The first supplier sells possibility. The mature supplier sells efficiency. AI is entering maturity unevenly. Frontier reasoning remains innovative. Routine language tasks are already commodities. One application can contain both stages. A frontier model plans the work. A cheap model executes it. The price war begins at the mature edges and moves inward. Every year, more tasks fall below the commodity line. Providers must move upward to maintain margins. The cheap models follow. This is the race between frontier expansion and cost compression. The frontier company needs new capabilities faster than old capabilities become cheap. If compression wins, intelligence becomes abundant and model margins collapse. If frontier expansion wins, premium models remain valuable. Both can happen. A market can support a thin high-margin frontier and a massive low-margin base. The base may generate more revenue in total because volume is enormous. The frontier may generate more prestige and strategic power. The title asks which may win. The answer depends on the definition of victory. The cheap model can win deployment. The premium model can win difficult work. The application company can win the customer. The cloud can win spending. The chip company can win infrastructure. The open ecosystem can win standard. The user can win lower prices. There may be several winners around one price war. There will also be losers. Weak AI wrappers with high model costs. Providers without scale. Applications that promise unlimited usage at fixed prices. Model companies unable to differentiate. Cloud customers who never optimize. Workers whose tasks become affordable to automate. Publishers and creators facing cheap synthetic output. Price competition spreads consequences beyond the API bill. When intelligence becomes cheap, every industry must decide what remains scarce. Trust, distribution, judgment, brand, physical asset, relationships, licenses, human attention. The cheap model erodes the value of generic production. Writing another standard marketing email becomes nearly free. Generating basic code becomes inexpensive. Producing routine images becomes ordinary. The economic value moves to deciding what should be produced and reaching the customer. This is why the cheapest AI model can win and still make many AI companies less valuable. If intelligence becomes a commodity, applications cannot charge only for access to intelligence. They must own outcomes. The price war forces the industry to mature. The application layer experiences the price war first. Imagine two AI companies selling the same product. Both charge $100 per business unit. The first uses a premium frontier model for every request. Its answers are excellent. Its inference cost consumes $40. The second builds a routing system. A small model handles routine question. A medium model handles common analysis. A frontier model receives only the hardest work. Its total inference cost is $10. The second company has more room. It can lower prices, spend more on sales, offer more usage, improve support, survive a downturn. The first company may have the better average answer in the weaker business. Gross margin becomes a product feature. Customers do not see it immediately. They feel it through limits, reliability, and price. A company with poor economics introduces message caps, slows heavy users, raises subscription pricing, removes features. The efficient competitor feels generous. Users describe one product as better value. The model architecture created the experience. This is why startups need cost engineering from the beginning. A prototype built on the strongest model can create a false sense of success. The demo works. Customers arrive. Usage grows. The founder discovers that every enthusiastic user produces a loss. Replacing the model later can change output quality. Prompts are tuned. Evaluations are missed. Customers notice. The company becomes trapped by its first technical choice. The best startup architecture assumes models will change. Abstract the provider. Build evaluations. Measure tasks. Log costs. Design routing. Limit unnecessary context. Use structured output. Cache repeated inputs. Batch non-urgent work. The startup creates freedom. Freedom becomes bargaining power. A provider offers lower prices. The company can move traffic. A new model performs better. The router tests it. This discipline prevents the model vendor from owning the application. Model companies understand the threat. They want developers to build provider-specific systems. A proprietary agent framework, unique to lay peers, stored memory, fine-tuning format, model-specific reasoning controls, integrated search, hosted files. The more services the developer uses, the harder switching becomes. The low token price can be the entrance. Locking creates profit later. Cloud companies perfected this model. Cheap compute attracted workloads. Managed services increased dependence. AI providers can do the same. The cheapest model may win adoption as a loss leader. Then the platform sells premium tools, priority capacity, enterprise security, and specialized agent. The initial price is not the final business. Customers should ask what the exit costs. Can prompts move? Can fine-tunes move? Can stored data be exported? Can agent tools use another provider? Can evaluations compare behavior? Can the company run an open replacement? The cheap model wins more safely for the buyer when standards remain open. Otherwise, low price becomes bait. This is not unique to AI. Printers can be cheap and expensive. Game consoles can be subsidized and software taxed. Cloud migration credits can be generous and egress costly. AI will create its own version. Free or cheap tokens. Expensive premium reasoning. Paid storage. Paid tool. Paid search. Paid priority. Paid data residency. Paid agent execution. The provider monetizes the full stack. The customer must calculate lifetime cost. The model price where can still create real savings. Competition limits abuse. Several strong providers exist. Open models create alternatives. Cloud platforms offer choices. The market is not controlled by one company yet. This gives buyers leverage. It also makes the market unstable. A provider cuts prices. Competitors respond. A model is released. Benchmarks shift. A once expensive capability becomes cheap. Developers delay commitment. Investors struggle to value model companies. Revenue can grow while price per token falls. Usage must rise faster than price decline. This is the central arithmetic of the model business. Suppose price falls by 80%. Usage must increase 5 times to preserve revenue. If usage grows 20 times, the company expands. If it grows only twice, revenue contracts. AI providers are betting on enormous elasticity. Cheaper intelligence will create so much more demand that total spending rises. This is plausible. The number of possible machine tasks is vast. Every mail, document, call, image, video, transaction, machine, customer, employee, software repository. AI can touch them repeatedly. The total token market can become enormous even at very low prices. The risk is that competition captures the demand without capturing profit. Telecommunications carried more data every year while connectivity became cheaper. Airlines moved millions of passengers and struggled with margin. Commodity industries can be essential and financially difficult. Model providers may become utilities. Large revenue, heavy capital, price competition, thin margins. The most profitable companies can sit above or below them. Chip providers below, applications above. The model layer in the middle gets squeezed. This is one possible future. Another future is oligopoly. Training frontier models remain so expensive that only a few companies survive. They compete on price but maintain discipline. Enterprise contracts, proprietary capabilities, and regulation protect margins. Cheap models exist inside each provider's family. The company routes customers within its own stack. The model layer remains profitable because competition is limited. The market resembles cloud computing. 3 or 4 giants, falling unit prices, growing total bills, strong platforms. Open source models are the uncertainty. They can prevent tight oligopoly. A company can self-host. A new provider can serve the same weights. Researchers can improve them. Governments can support alternatives. Open models reduce the ability of closed providers to set high prices and mature capabilities. They may not eliminate frontier premiums. They pressure the base. The cheapest model may therefore be open, while the most profitable provider sells hosting and support around it. Red Hat built a business around open software. Cloud companies built businesses around open databases and Linux. AI can follow. The weights are available. The enterprise pays for reliable deployment. Security patches, optimization, indemnification, aid to governance. The model is cheap. Trust is expensive. This reinforces the main thesis. The winning model and winning company can be different. An open model can win usage. A cloud can win revenue. A chip company can win profit. An application can win customers. The model creator can win influence and little direct money. Meta's open model strategy illustrates this logic broadly. A company earning from advertising and social platforms does not need model API and origins in the same way as a pure model laboratory. Open models can reduce dependence on competitors and expand the developer ecosystem. The strategic value sits elsewhere. Google can price models aggressively because AI protects search, cloud workspace, Android, and advertising. Microsoft can subsidize AI through cloud and software relationship. Amazon can use models to drive AWS consumption. A pure frontier laboratory needs model and product revenue more directly. Its pricing freedom is different. This is why the cheapest model may come from the company with the largest adjacent business. Cost subsidy is a weapon. A company earning money from hardware can give away software. A company earning from commerce can offer free search. A company earning from advertising can provide free assistance. The specialist must charge for what the conglomerate bundles. The specialist can survive through superior quality and focus. It faces a structural disadvantage on price. This battle will repeat across consumer AI. A standalone writing assistant charges a subscription. The operating system adds writing tools for free. A meeting note startup charges per user. The productivity suite includes summarization. A coding tool charges monthly. The development platform bundles an agent. A search service charges for research. A general assistant adds SERP. The model price decline enables bundling. Features disappear into larger products. The customer pays through an existing relationship. The cheap model becomes the engine of software deflation. Startups need deeper differentiation, workflow, community, regulatory approval, physical operation. A feature built only on model access becomes vulnerable. This can be healthy. Weak wrappers disappear. Strong products remain. It can also strengthen giants that control distribution. Low-cost intelligence is easier for a platform with billions of users to spread. The best model may not win if it lacks a channel. Price and distribution multiply. A cheap model with no users does not matter. A slightly more expensive model built into every phone can dominate. The winning economics combines several variables: model cost, distribution cost, customer acquisition, retention, integration, quality. A company can pay more for inference and less for distribution. Another has cheap inference and expensive marketing. Total business cost decides. This is why Google, Microsoft, Apple, Meta, Amazon, and device makers remain central to the A race. They already own road. The model startups own vehicles. The cheapest trip depends on both. The consumer rarely compares token prices. The consumer sees free, $20 or included. Retail packaging hides infrastructure economics. A free assistant can use a cheap model most of the time and premium capability behind limit. The user receives an apparently unlimited product. Advertising or ecosystem value finances it. The subscription provider must convince users that quality differences matter. As cheap models improve, that becomes harder. Premium assistants will sell more than answers. Privacy, research, coding, media generation, high limits, priority. The model becomes part of a membership. This is another sign that raw intelligence is commoditizing. Companies bundle experiences to preserve willingness to pay. The enterprise market hides prices differently. Volume discounts, committed spend, cloud credits, negotiated contracts. A public API table is the starting point, not the final rate. Large customers can create competition between providers. They run bake-offs, move workloads, demand price protections. The cheapest model can win a contract worth millions. Reliability requirements can reverse the result. An enterprise saves money only when capacity exists at peak time. A low-priced API that slows or rejects traffic is not cheap. Service quality matters. Guaranteed throughput has value. Priority processing has value. Support has value. The provider can charge for certainty. This creates price tiers around the same model. Standard, batch, flex, reserved. The customer buys a combination of intelligence and service level. The model may be cheap. The reliable delivery is premium. This resembles electricity. Power has a unit price. Grid reliability and capacity require infrastructure. Inference becomes a managed utility. Regulation can affect the price war. Data residency increases operating complexity. Privacy rules limit where requests can run. Safety requirements add evaluation. Copyright obligations can add licensing cost. Export controls shape hardware availability. Energy regulation affects data centers. The cheapest global model may not be cheapest in every region. Compliance creates local markets. A European enterprise may pay more for regional processing. A government may require domestic hosting. A healthcare company may choose a provider with certification and contractual protection. The low-cost model needs a governance wrapper. The wrapper adds price. Regulation can protect high-quality providers from race to the bottom competition. It can also protect incumbents. A small, low-cost provider may not afford audits, legal teams, and regional infrastructure. The market consolidates. Cheap models remain through large platforms or open deployments. The relationship between safety and cost is complicated. A cheaper model can be safer for a narrow task because it has less capability and limited. It can also be less reliable. A premium model may follow instructions better. It may create more dangerous output if misused. The company must match capability to authority. Do not give a weak model a high-risk ask simply because it is cheap. Do not give a powerful model unnecessary permissions simply because it is cost optimization without risk optimization creates accident. A financial agent making payments should be evaluated on error cost. A customer service classifier can tolerate more mistakes. The expected loss belongs in the equation. Model cost plus probability of failure multiplied by consequence. This is total risk-adjusted cost. A cheap model causing one serious incident can erase years of savings. Insurance and governance teams will care. AI procurement will become similar to financial risk management. Expected value, tail risk, controls, human approval. The cheapest model wins only inside a defined risk envelope. This protects premium models in high-stakes use cases. It also creates demand for small specialized models with strong guarantees. A narrow model can be easier to test. Its behavior is bounded. The company may provide over a general frontier system. Cheaper and more governable can be a powerful combination. Robotics makes the economics physical. A robot can make many model calls every second. Vision, control, language, safety. Cloud inference can add latency and network cost. Local models become necessary. Efficiency affects battery life, heat, hardware, and response time. The cheapest model is not measured only in dollars per token. It is measured in watts and milliseconds. A model that uses less power can make a robot smaller and cheaper. That changes the entire product. The same is true for vehicles, drones, cameras, and industrial equipment. Model efficiency reduces bill of materials, extends battery, allows offline operation. The cheap model can unlock physical AI. A frontier cloud model may plan complex tasks. A local model handles continuous perception and control. The hierarchy returns. The volume at the edge can dwarf cloud conversation. Billions of devices running small models create more total inference than a smaller number of premium requests. The winner may be a model architecture optimized for edge hardware, not a famous chatbot. This is why chip and device companies build their own small models. They want co-design. The model fits the processor. The processor fits the model. Together they lower system cost. The provider offering only a cloud API misses the market. Voice AI also rewards cheap models. A natural conversation produces a continuous stream. Speech recognition, language understanding, response generation, text-to-speech, interruption detection. A service running for hours can consume large resources. A premium model for every turn makes unit economics difficult. Cheap real-time models make call centers, tutors, game characters, and personal companions possible. Latency matters as much as depth. The user notices a pause more than a small benchmark difference. The cheapest fast model can win the conversation layer. High-volume voice can become one of the largest inference markets. Advertising-supported companion, customer support, and device assistance require extremely low cost. The provider reaching the threshold gains distance. Search has similar dynamics. Most queries are simple. Navigation, facts, weather, definition, product lookup. A frontier reasoning model is unnecessary. A cheap search model handles them. Complex research escalates. The provider protects margin through routing. The consumer experience is one search engine. The system uses several intelligence levels. The company with the lowest blended cost can offer better free access and preserve advertising profit. The model price war connects directly to the search war. Coding agents create the opposite pressure. Some tasks are long and difficult. A weak cheap model can enter loops, generate flawed code, waste tool calls. The premium model may be cheaper per completed issue. Coding platforms will measure success rates. A small model can still handle search, formatting, tests, and simple edits. The agent architecture combines them. The cheapest model wins components. The strongest wins planning. This fragmentation makes benchmark marketing less useful. iModel can be second best overall and best for a profitable subtax. The market will develop more specialized evaluations. cost per resolved support ticket, cost per accepted code change, cost per verified research report, cost per accurate extracted field, cost per completed purchase. These metrics connect AI to business. Providers will market outcome economics, not tokens. A company can claim a higher token price and lower cost per result. The customer will demand independent evidence. Evaluation platforms become powerful. They can expose whether cheap models actually save money. The benchmark industry evolves into a procurement industry. This creates an opportunity for marketplaces. Submit the task. Several models compete. The platform measures quality and cost. Traffic goes to the winner. Prices update. The model market becomes dynamic. A provider can cut price to capture volume. Another improves a capability. The router responds. This resembles online advertising auctions. Models bid to handle intelligence. The buyer defines constraints. Latency under 1 second. Accuracy above 98%. Data must stay in region. Cost below 1 cent. The marketplace selects. This would make AI highly competitive and highly commoditized. Providers may resist by building closed ecosystems. Customers will support interoperability. The outcome determines who captures margin. If marketplaces win, the application and routing layers gain power. If vertically integrated platforms win, model providers keep control. The cheapest model may win within a marketplace. The integrated model can win outside one. The labor market feels the price decline through automation threshold. A task worth $5 is not automated by a model costing 10. At 50 cents, the economics change. At 5 cents, the company automates by default. Falling prices move the boundary. Low-value tasks become addressable. This affects more jobs than frontier capability alone. A brilliant model that costs too much remains a tool for specialists. A good enough model that costs almost nothing enters every workflow. The cheap model can have the larger labor impact. This is another reason the title matters socially. The most disruptive AI may not be the smartest. It may be the one price below human attention. A company compares the cost of asking an employee with the cost of asking a model. The employee may provide better judgment. The model is instant and cheap. For routine work, price wins. The employee moves to exceptions or loses the task. As model cost falls, the definition of routine expands. This can increase productivity. It can concentrate income. Owners of software capture savings. Workers must move toward scarce capabilities. The economic consequences depend on distribution. Cheap intelligence can empower small businesses and individuals. A freelancer gains research, coding, design, and translation. A startup competes with a large company. A teacher creates materials. A local business automates support. Lower cost democratizes capability. The same technology allows large companies to reduce hiring. Both effects happen. The cheapest model can distribute power and centralize it. Distribution depends on access and ownership. An open local model gives the user control. A cheap centralized A, but gives the provider data and leverage. The price can be the same. The political economy is different. This is why cheap should not be confused with open. A company can subsidize an API and create dependence. An open model can require expensive hardware. The user must examine control. Can the model be run elsewhere? Can the price change? Can access be revoked? Can data remain private? Can output be audited? Economic. Some customers will pay more for it. The cheapest model may win mass adoption. A more expensive sovereign model wins strategic use. Competition will not converge to one answer. The most likely future contains layers. At the top, a small number of frontier systems solve the hardest problems. Below them, efficient general models handle common knowledge work. Below that, specialized and local models perform narrow tasks. Routers connect the hierarchy. Agents call several models. Open and closed systems coexist. Cloud and edge divide the workload. The user sees one product. The infrastructure resembles an organization. This is not one winner. The title points to the layer with the most calls. The cheapest qualified model becomes the default employee. It can process the majority of machine work. That creates scale, ecosystem, and strategic importance. The frontier model remains the executive consultant. The default model runs the company. What could prevent the cheapest model from winning? Quality differences remain large. Users develop strong brand loyalty. Regulation favors trusted providers. Model providers create unique ecosystems. Hardware cost stops falling. Energy becomes scarce. Open models fail to keep pace. Enterprises refuse multi-provider architecture. Security risks make routing difficult. A breakthrough creates a durable capability gap. Any of these could preserve premium dominance. The history of computing suggests cost compression remains powerful. Software optimizes. Knowledge spread. Customers demand discounts. Competition arrives. The premium capability eventually becomes standard. The question is speed. AI compression is happening unusually fast. A model released at the frontier can be challenged quickly. Techniques spread through papers, staff movement, open code, and observation. The market has global competitors. Capital is enormous. The incentive to undercut is strong. This favors the cheap layer. The frontier will continue moving. The cheap models will continue following. The business winner may be the company best at both. Train frontier systems. Distill smaller versions. Offer a complete family. Route traffic internally. Use one ecosystem. Google follows this logic with Pro and Flash style tiers. OpenAI offers Frontier, Mini, and Nano style choices across generation. Anthropic offers Opus, Sonnet, and Haiku families. DeepSeek offers larger and faster, lower cost options. The names change. The portfolio strategy remains. A provider does not want the cheap model to be a competitor. It wants the cheap model to be its own product. The family protects market share. Premium users stay. Volume users stay. Developers grow without leaving. The provider learns across workload. This can be the winning corporate strategy. One brand across the intelligence ladder. The risk is internal cannibalization. Customers move from expensive models to cheap ones. Revenue per token falls. The provider must encourage migration when it lowers costs without reducing value. If it resists, competitors capture the workload. Cannibalize yourself or be cannibalized. Google learned this lesson in cloud and search transition. Every model company faces it now. The price page becomes a strategic document. It signals where the company wants traffic. A new cheap tier can attack rivals. A cash discount encourages architecture. A batch discount fills unused capacity. A priority premium monitors this urgency. Pricing shapes developer behavior. It is not only accounting. The most sophisticated providers will use dynamic pricing, off-peak discounts, committed spend reductions, regional rates, spot capacity, quality tiers, agent bundle. The cost of intelligence can fluctuate with demand. Customers will build financial controls. The market begins to look like energy and cloud. The cheapest model at noon may differ from the cheapest at night. A router can move workloads automatically. Price becomes software. This increases efficiency. It can make budgeting difficult. Enterprises will seek predictable contracts. Providers will sell predictability at a premium. Again, the cheap commodity creates profitable services around it. The long-term price floor is not zero. Hardware, electricity, staff, networking, and capital cost money. The provider can operate below cost temporarily. Not forever without another revenue source. Efficiency determines the sustainable floor. Companies with scale spread fixed costs across more tokens. They negotiate energy and chips. Optimize software. Use proprietary hardware. Pay utilization lowers unit cost. Scale creates a cost moat. The largest provider can become the cheapest. The cheapest attracts more volume. Volume improves scale. This is a powerful flywheel. It can produce winner-take-most economics. Open source competition and customer diversification can limit it. The market is balancing the forces. Scale centralizes. Open technology decentralizes. The outcome remains uncertain. A provider with the lowest sustainable cost and enough quality is the strongest decision. Sustainable is the key word. Subsidized prices can win a year. Efficient infrastructure can win a decade. Customers should look beyond the offer. Does the provider have capacity, capital, hardware access, revenue, a path to margin? A cheap model disappearing is expensive. Reliability over time belongs in total cost. This is why the final winner may not be the absolute lowest bidder. It may be the low-cost provider customers believe will survive. Walmart did not win only by displaying a low number. It built supply chains capable of sustaining low prices. Southwest did not become a low-cost airline only by discounting tickets. It designed operations around efficiency. The AI winner needs the same discipline. Architecture, hardware, serving, product, and distribution all designed for low cost. A temporary price cut is not a business model. Ecosystem is. The company that builds that system can define the market. Competitors must match its price or justify a premium. Customers redesign products around abundant intelligence. The low-cost provider becomes infrastructure. This is the strongest version of the thesis. The cheapest AI model may win because price does not only attract customers, it changes what customers build. A model costing $10 per task supports occasional use. A model costing 10 cents supports a feature. The model costing a fraction of a cent supports an environment. It can run continuously, watch every event, assist every employee, live on every device. The lower price creates a different world. The premium model competes inside existing demand. The cheap model creates demand that did not exist. That is how it can win. The first wave of AI asked whether machines could produce useful intelligence. The next wave asks how cheaply intelligence can be produced, delivered, and trusted. The answer will decide which products survive, which jobs change, which countries participate, which companies earn margins, which platforms become standards. The benchmark leader may change every few months. The cost leader can reshape the structure of the economy. Still, the cheapest model should not be worshipped. Low price can hide poor quality. Subsidy, dependent, weak security, unstable service, limited support, political risk. The disciplined buyer asked for total cost per successful, safe, reliable outcome. That phrase contains the whole market. Success, the task works. Safe, the failure does not create unacceptable harm. Reliable, the service is available and consistent. Outcome, the model creates business value. The cheapest provider meeting all for can win. Not every benchmark, not every user, the majority of work. That may be enough. The economic history of technology is full of products that began as miracles and ended as utilities. Electric light, telephone calls, computing, storage, bandwidth. The miracle becomes cheap. The cheap version spread. The spread changes society. Artificial intelligence is moving along the same path. Today, companies celebrate a model solving an extraordinary problem. Tomorrow, the bigger story may be a model solving an ordinary problem 1 trillion times. The extraordinary task proves intelligence. The ordinary task creates revenue. The model that can do both at the lowest sustainable cost becomes difficult to beat. The strongest AI may define the frontier. The cheapest useful AI may define everyday life. That is why the cheapest model may win.